Hello and welcome to Hydescience Lab Series video number one. So in this series, we're going to start out very slow and very basic with some basic lab tools that we use and some skills that we use throughout the course. And we're going to progress throughout the year with which one of these videos. So video number one, the microcentrifuge or the centrifuge. So today's objective for the students is to just get some hands-on time with the centrifuge and kind of visualize and get to interact with some of the key components of why we use the centrifuge and the pieces of the centrifuge. Um, and yeah, that's it. So we have the centrifuge here. Some important pieces of the centrifuge is you have some kind of way to open it, a lid, and this is the rotor. So our rotor, these centrifuges have different amount of spaces around the rotor in which you can load tubes. So today we're going to experiment with a couple different things. We have four tubes here. So we kind of practice our labeling techniques. I don't know if you can see that, but we kind of label it, put our initials and dates on it somewhere. Right, so what I have here, I have some pureed tomato, some apple juice. This is a yeast culture and a sweet potato baby food. So we're going to centrifuge these up and see what happens. So it's important when we're loading our centrifuge that we want to counterbalance the tubes as we put them in there. If we do not balance them, then it's going to get real rocky and real shaky. So the best way to do it with these here is as so. So you see I have the two spaced out and there is one empty spot between them. So this is going to give us a balanced spin. It's also important that you use the correct amount or the same amount throughout the tubes. So in these tubes, I have 1 milliliter of the sample in each tube. So if I loaded this side up and had 2 mils in each tube, or half a mil over here, then that would, even though they're spaced out correctly, it would still not give us a balanced spin. So I'm gonna close this down and we're going to turn it on. This one has a turn on here. So I'm gonna turn that on, let that spin a second. All right, so let's open it up and see. So when we are done spinning, we've reached our time. I don't know how long that's been. I should have timed it, but probably about 30 seconds or so. So we're going to turn it off. We're going to allow it to come to a stop, and then we'll open it up. Let's let it go a little bit longer. So again, the spinning piece is the rotor of the centrifuge tube. And what we're hoping to see here when we take these tubes out is that the substance inside of the tubes will separate by their densities, with the more dense, the more compact things inside of the mixture getting thrown by the centrifugal force, centripetal force to the end of the tube, and then the less dense things remaining in suspension higher up in the tube, which is what we hope to see. So just give us another second. The matter that gets spun to the end, right, to the tip of the tube, should form a nice little ball. We call this the pellet. And then the suspension above the pellet is the supernatant. So that's kind of our three main focus areas today is the rotor, how to balance, how to counterbalance that correctly, the pellet, and the supernatant. All right, let's see what we got. Almost there. All right, so I just kind of paused this up for a minute. This took several minutes. I did not time it. I apologize for that. Probably 4 or 5 minutes in the centrifuge. So we're going to stop it. We're going to allow it again to come to a stop before we start opening it and moving it around. And we'll see what we got. So here's our yeast suspension. We know that because we did label it. So we know what we had in it originally. So um, not great view here. Let's see if we can enhance visuals a little bit. All right, so yeah, so we see that we have a clear suspended section here, and then we have this nice little pellet that's formed at the bottom. So this is our pellet, and this is our supernatant. This is the more dense stuff that was in the mixture. This is the less dense things that are still suspended. Then we got sweet potato puree. So not quite as clear, probably a bad color, but you can still kind of see all the sweet potato gathering at the bottom of the more dense and the clearer supernatant liquid above. We got the tomato puree here. So this one formed a pretty cool layer. So we have three layers here, with the most dense being in the pellet down here. Then we have a less dense layer of water. And then we have an even less dense layer of, looks like, some plant matter and things of that nature. Pretty cool. And finally, the apple juice. Did not turn out real well. We can still kind of see some solids collecting at the bottom there, trying to form a pellet, and a little clearer mixture there at the top. So that's a centrifuge. We have a rotor. We want to balance the rotor. If we don't balance it, it'll get out of balance and it'll start rocking on the table. And we don't want that because it can damage our equipment. And it is more hazardous to be around than if it's sitting there spinning smooth. So a big key takeaway is rotor. Balance the rotor and how you space them. If I was only needing to centrifuge one tube, well, how do I balance that? You would get you just an empty tube and put the same amount of water that you have of the mixture in this substance. So if you have 1 milliliter in this, just put 1 milliliter of water in your other tube, put it directly across, and that will balance that one tube. And then we have our pellet and our supernatant. So we have separated this mixture by the density using the centripetal force provided by the centrifuge. All right, y'all catch us for lab series number 2 coming up. See y'all then.